Hello, you absolute legends. This board is set up with the idea that you have done a titration with this balanced chemical reaction, and there are blanks for moles that we're going to fill in, calculate, logic our way through. So if you're not familiar with the titration, please check out one of those videos. So you have titrated in the tube, in the titration tube, an acid, and at the bottom was a base. You measured the volume and you knew the molarity of that acid. So you very quickly can calculate how many moles of acid you use to get to the equivalence point. So in this example here, 3 moles. Just say 3 moles of acid we used right here. This is a monoprotic acid, and if we look at our balanced chemical reaction in our formula, we can logic out the rest of these moles and not have to use a scaffold or calculate from scratch here. If we used 3 moles of HCl and the reaction was neutralized, looking at the balanced chemical reaction can tell us how many moles of calcium hydroxide must have started with. So based on this reaction here, based on this ratio, we must have started with 1.5 moles of calcium hydroxide because of that 2-to-1 ratio here. Takes more acid than base, twice as much more. That logic right there. So if you have 1.5 moles of calcium hydroxide, one of the things you need to calculate KSP is the Ca2 plus. Well, it's for every one, this is a 1, put an imaginary 1 there. For every 1 molecule, 1 calcium ion is released. So these numbers logically are identical. Okay. Now, because dose hydroxides are released for every 1 molecule, this here is doubled right here, okay? I remember when I was a young learner, this always felt like denying conservation of mass and energy. If I started with 1.5 moles, how do I end up with more at the end here, okay? You don't end up with more. We change how we count. Here, we are counting all together. Here, we are counting the split up. Remember, when this ionic compound goes into water, into solution, it splits up into its cations and anions. So this thing splits up and produces 2 of these right here. A way I kind of think about this is like if I take a car and I dismantle a car. If I dismantle 1 car, I end up with 4 tires. That doesn't violate conservation of mass and energy because 1 car happens to contain 4 tires. So when I split them up, I can see the parts out in front of me. Continuing on with the moles of chloride that must have been present. This is also logicked out because if we started with 3 moles of HCl and it's a 1-to-1 ratio here, we're going to have 3 moles of Cl that were in the solution floating around here. Now we have the items we need to calculate the capital K expression for this acid-base reaction. I hope this helps. Thank you.